The rise of mathematical probability. There are earlier records of mathematics applied to games of chance, but the beginning of the theory of probability is generally identified with the 1654 correspondence between the two French mathematicians Blaise Pascal, 1623-1662, and Pierre de Fermat, 1601-1665, concerning the so-called problem of points in gambling. The question was how to divide the stakes between two players who part before completing the game. To arrive at the solution, Pascal introduced the binomial distribution for p equals 0.5 and found the coefficients by means of the arithmetical triangle, a curious numeric structure now named after him. In 1657, the Dutch mathematician Christiaan Huygens, 1629-1695, published his monograph De Ratiociniis in Ludo Eli, Reasoning on Games of Chance, the first printed mathematical treatment of games of chance. In these games, equally likely outcomes, such as the 6 faces of a balanced die, were the assumption that led to the classical definition of probability. The first major work devoted to probability theory was Ars Conjectandi, The Art of Conjecturing, by the Swiss mathematician Jacob Jacques Bernoulli, 1654-1705, published in 1713. It contained the first form of the law of large numbers. The history of probability is crucial as it provides insights into the development of mathematical concepts, the evolution of decision making, and the foundations of statistics. It allows us to understand how ideas of uncertainty and chance have shaped various fields, including science, economics, and even everyday life. Studying its history helps in comprehending the origins of probability theory and its applications in diverse disciplines, aiding in the advancement of predictive modeling, risk assessment, and decision sciences. The scientific study of probability is a modern development of mathematics. Gambling shows that there has been an interest in quantifying the ideas of probability throughout history, but exact mathematical descriptions arose much later. There are reasons for the slow development of the mathematics of probability. Whereas games of chance provided the impetus for the mathematical study of probability, fundamental issues are still obscured by superstitions. According to Richard Jeffrey, before the middle of the 17th century, the term probable, Latin probabilis, meant approvable, and was applied in that sense, univocally, to opinion and to action. A probable action or opinion was one such as sensible people would undertake or hold, in the circumstances. However, in legal contexts especially, probable could also apply to propositions for which there was good evidence.
The power of probabilistic methods in dealing with uncertainty was shown by Gauss's determination of the orbit of Ceres from a few observations. The theory of errors used the method of least squares to correct error-prone observations, especially in astronomy, based on the assumption of a normal distribution of errors to determine the most likely true value. In 1812, Laplace issued his Theorie analytique des probabilités, in which he consolidated and laid down many fundamental results in probability and statistics, such as the moment-generating function, method of least squares, inductive probability, and hypothesis testing.
Pierre de Fermat, French, between the 31st of October and the 6th of December 1607 to the 12th of January 1665, was a French mathematician who is given credit for early developments that led to infinitesimal calculus, including his technique of adequality. In particular, he is recognized for his discovery of an original method of finding the greatest and the smallest ordinates of curved lines, which is analogous to that of differential calculus, then unknown, and his research into number theory. He made notable contributions to analytic geometry, probability, and optics. He is best known for his Fermat's principle for light propagation and his Fermat's last theorem in theory, which he described in a note at the margin of a copy of Diophantio's Arithmetica. He was also a lawyer at the Parliament of Toulouse, France.
Christiaan Huygens, Netherlands, 1629-1695, was an astronomer and inventor famous for inventing the pendulum clock. After a visit to Paris and learning of Pascal and Fermat's work, he wrote on Reasoning in Games of Chance, 1657, the first book on probability to be published. Ronald Fisher, UK, 1890-1962, developed his ideas at an agricultural research station, and had a major influence on the design and analysis of biological experiments. He developed the concepts of null hypothesis and p-value, as well as likelihood and maximum likelihood estimation. Like Pearson, he insisted that only the data from the current experiment could be used, and using prior information was unscientific. Fisher described Bayesian estimation as founded upon an error, and must be wholly rejected. Such was Fisher's influence, that few statisticians dared use Bayesian analysis during his lifetime.